Hi, good day, engineers again. So this is the part two for chapter one. This is internal combustion engine. Okay, so let's continue the discussion of it. So let's now move with the refinery process. Okay, so refinery process is the process in which you convert the extracted crude oil underground or under earth. Okay, so you transfer it or transform it into a usable one, such as petroleums, including gasoline, diesel, and heavy fuels. Okay, heavy oils. Okay, so let's dig deeper on it. So firstly, this is refinery process. So what you have been getting from the reserves, that's crude oil. So this is the liquid part of the naturally occurring organic material composed mostly of hydrocarbons. Again, hydrocarbons is the compound used to, or this compound is the uh, primary part of your fuels. Okay, this is trapped geologically in underground reserves. It is not uniform and varies in density, chemical composition, boiling range, etc. for different fields. Okay, let me first have here the refinery processes. Okay, so crude oil undergo different processes. So let me have here first diagram. So crude oil undergoes atmospheric distillation. So if it undergoes the next process, which is fractionalizations, it would produce refinery gas, LPG, and if undergoes another process from fractionalization to catalytic reformer and add some additives, you get the gasoline blending. Okay. Another type of process or another process is the hydrotreater. So if your atmospheric distillation undergoes hydrotreater, you'll get the kerosene or jet fuel. Next is the diesel. And for side stream, you'll get the heavy gas oil and residue, that's fuel. Okay, that's your first process. I mean the refinery process as your first diagram. Okay, now let me have here the processes of refinery. So your crude oil as extracted from underneath. Here, you extract this. Then it will go refinery process, at which your first is the distillation process. Okay, followed by cracking process, then alkylation, isomerization, and lastly polymerization. Okay, that's refinery process. So first is the distillation process, followed by the cracking process. The third is alkylation. The fourth one is isomerization. And lastly, polymerization. Okay, that's your five process of refinery. So firstly, let's discuss the distillation process. Okay, distillation process is your initial process. Okay, it aims to separate crude oil into different boiling range fractions. Okay, our fuels or what we've been extracting from different ranges of temperature, that's their specific extraction, okay, or boiling range. So that's distillation process. So we have here the first um, graph or the temperature ranges. Okay, let me have here for less than 40 degrees, you'll get the bottle gas, specifically the gas, the gasoline or yung mga nasa gasol. So that's basically bottled gas. So for petrol, that's 40 degrees to 205 degrees Celsius. Petrol, that's for gasoline. That's for automobiles or vehicles. For 60 degrees to 100 degrees Celsius, you'll get the chemical, namely naphtha. For 175 degrees Celsius to 325 degrees Celsius, you'll get kerosene. So kerosene, commonly used in the planes or jet fuel. Okay, next you do get diesel. Diesel as 250 degrees Celsius to 350 degrees Celsius. Diesel fuels. So you can extract lubricating oil at temperature 300 degrees Celsius up to 370 degrees Celsius. For fuel oil used in the ships, in factories, and also in central heating at temperatures 370 degrees Celsius to 600 degrees Celsius. And lastly, if it is greater than 600 degrees Celsius, you'll get the residue or residua. This residua is known as bitumen. So bitumen po is known for its other name, which is asphalt. Okay? Yung inilatag natin na color black sa mga roads natin, or the black-white part, or the black sediments folded on our roads. Okay? That's the distillation process. Okay? Aiming to separate the crude oil into different boiling ranges. Okay, so let's focus on the temperatures of specific internal combustion fuels, okay, or internal combustion engine fuels. So we do have the gasoline for temperatures 35 to 200 degrees Celsius. For jet fuel, that's 35 to 150 degrees Celsius. For diesel fuel, we do have the 175 to 370 degrees Celsius. And for heavy fuels or oils, that's 370 to 550 degrees Celsius. Okay, again, that's the distillation process. Distillation process aims to separate crude oil into different boiling temperature range. Okay, it's basically distillation. So the next one is we do have the cracking process. Okay, the cracking process. From the word cracking, it's just simply breaking up. Okay, breaking up large hydrocarbon molecules into smaller and more useful bits. Okay, for example, this is your large hydrocarbon. Then you'll be splitting this up into smaller bits. Okay, so this mainly the small bits is also composed of hydrocarbons. You're just breaking it up. Okay, so we do have two process to achieve cracking process. Okay, so firstly is with catalytic. Okay, with catalyst and without catalyst. Okay, so if you'll be using the process with catalyst, you'll just need low pressure and low temperature, while if without catalyst, you'll be getting or using high pressure and high temperature. Okay, that's the two process with and without catalyst. If with catalyst, low pressure and low temperature. If without, you'd need high pressure and high temperature. Okay, we do have two cracking process specifically. That's thermal cracking and the catalytic cracking. Okay, so thermal cracking takes place through the creation of hydrocarbons free radicals to C bond scission. Okay, carbon to carbon scission, bond scission. And with catalytic cracking, it is the most important and widely used process for converting heavy refinery streams to light products. Okay, so thermal cracking is just like this. You'll be breaking this into two equal parts. The carbon is being um, split into two. Okay, that's C bond. Then we do have here the catalytic cracking. Okay, your zeolite catalyst will get those free radicals. Okay, now we do have the third one, that's alkylation. So for alkylation, it is a process of producing high octane gasoline, a component which is known as alkylate. It is by combining light olefins with isobutane in the presence of strongly acidic catalysts such as sulfuric or hydrofluoric acid. Okay, alkylation, alkylate. Okay, it's just the process of producing alkylate. Okay, that's the third one. So the fourth one is isomerization. So isomerization is the process of converting straight chains of paraffins to branch chains. So take note of this. It is to convert a relatively low octane quality of straight paraffins to more valuable branch chain molecules. So that's isomerization. Okay? And lastly, we do have the fifth one, polymerization. polymerization. So this is the process where light olefins such as propane and butanes are reacted together to give heavier olefins which have good octane quality and low vapor pressure in gasoline. Okay? Combining um, light olefins, I mean olefins reacting together to give heavier olefins. Okay? That's polymerization. So I hope you do get the five refinery process. Okay, let me just go back to the um, this process. So again, the refinery process we do have five. So first is distillation process, followed by cracking process. The third one is the alkylation. The fourth one is isomerization, and lastly, the fifth one is polymerization. Okay, I hope you do get the refinery process. Okay, let's move the next one. Okay, let's move with the alternative fuels. Okay, we have discussed one of this on our part one. So that's first is alcohol. Okay, but before that, let me write here the third alternative fuels. We do have the first one, that's alcohol. Alcohol. The second one is the blast furnace gas. And the third one is the coke oven gas. There you go. We do have the three again. That's alcohol, the blast furnace gas, and the coke oven gas. Okay? So here's the alcohol. So alcohol is its examples, okay? We do have the methanol, also known as the methyl alcohol, the ethanol, which is the ethyl alcohol, the propanol or propyl alcohol, and lastly the butanol, that's butyl alcohol. Okay, that's alcohols. So as you can see, it is not really used as an alternative one on today's, but think of it, alcohol lights off when you flame it. Okay, that means it ignites when in contact with flame. Okay, I'll be furtherly discussing what kind of properties it do has. Okay, let's move with the blast furnace gas. So blast furnace gas is a byproduct of melting iron ore in steel plants. Melting iron ore. Okay, so it principally consists of carbon monoxide. Monoxide, there you go, that's CO. Then blast furnace gas can be combined with natural gas or coke oven gas. Okay, so commonly the blast furnace gas is combined with natural gas or coke oven gas. Since also the blast furnace gas contain high concentration of carbon monoxide, it is hazardous. Okay, too much carbon monoxide can cause a great danger. Okay, so that's blast furnace gas. Again, it is made from or a byproduct of melting iron ore and consists of carbon monoxide, which is hazardous since it do has high concentration of carbon monoxide, and it is combined with natural gas or coke oven gas. Okay, that's blast furnace gas in internal combustion engine. Next, we do have the coke oven gas. So it is produced during the making of coke. So this coke is not a drinkable one. Okay, so this is somehow a type or somehow correlated with coal. Okay, it is also resulting from oxidation reduction reactions of coal or coke with air and sometimes steams. Okay, and that is your coke oven gas. Okay, any questions with the three? Again, we do have the alternative fuels, which is the alcohol, the blast furnace gas, and lastly the coke oven gas. Okay, now let's move with the topic. This topic is the general fuel specifications. Okay, now we do have here the relative density. So relative density is also known as specific gravity. Okay, it is the ratio of a given volume of fuel to the weight of the same volume of water, both at normal condition. So what is normal condition? That's 20 degrees Celsius and 101.325 kilopascal. That's relative density. The ratio of weight of a given volume of fuel to the weight of same volume of water. Okay, let's move with the specific heating value. Okay, specific heating value is, you can say it is LHB or HHV. Okay, so lower heating value is LHB, lower heating value, while HHB is your high heating value. Okay, so it is a measure of energy content of the fuel per unit mass. Its unit is kilojoule per kilogram or kilocalories per kilogram, or in English, BTU per pound. That's your specific heating value. Okay, so furthermore, heating value of the combustible air fuel mixture is a decisive factor for engine performance, and that is specific heating value. Now let's move with the flash point. So flash point is the lowest temperature of a sample at which the fuel vapor starts to ignite when in contact with flame. So that's technically and basically um, interpretation of it. So that's the lowest temperature at which your liquid or your fuel is when in contact with flame, specifically fire, it will ignite. Okay? In Tagalog po, ito po yung pinakamababang temperature na kapag sinilaban mo is magliliyab. Okay? So flash point for gasoline, you do have 25 degrees Celsius. For diesel, that's 35 degrees Celsius. And for heavy diesel, that's 65 degrees Celsius. That's the lowest temperature at which it will ignite when in contact with an ignition source. Okay, that's flash point. So we do have here another term, which is the viscosity. Okay, it is an important parameter for for compression ignition engines. Okay, take note that the lower the viscosity, the smaller the diameter of the droplets in the spray. That's viscosity. Okay, again, viscosity, the lower the viscosity, smaller the diameter of the droplets in the spray. Okay, that's viscosity. Next, we do have the surface tension. So it is a parameter which affects the formation of fuel droplets in spray. So for example, we do have here the droplet. Okay, this is the liquid one. Okay, surface tension is what you call, or what you observe in these parts with the arrow one. Yan. Ito siya. Surface tension. Okay, so we do have the diesel fuel range for surface tension at 0.023 or 23 to 0.032 Newton meter, and for gasoline that's 0.019 to 0.023 Newton meter. Okay, gasoline and diesel fuel, that's the surface tension. Okay, now we do have the freezing point. So freezing point is the as from the word freezing, it is where it becomes solidly cold. Okay, that's the freezing point. So we do have here the freezing point for gasoline, that's negative 65 degrees Celsius, and for diesel, that's negative 10 degrees Celsius. That's freezing point. Okay, now let me move with the are we good with the general fuel specification? That's specific gravity, specific heating value, the flash point, viscosity, and surface tension. Lastly, the freezing point. Okay, are we good with that? Okay, I hope you do follow. Okay, let's now move with the testing and performance. Okay, for testing and performance, let me start with the engine performance. Okay, so engine performance is the degree of success of the engine performs its assigned task. Okay, that's engine performance. If you are asked to evaluate the engine performance, you are asked to evaluate the following. Okay, firstly, the specific fuel consumption. Next is the brake mean effective pressure or BMEP. Okay, next is the specific power output. Next is specific weight. And lastly, exhaust smoke and other emissions. Okay, that's the five your task to evaluate when you are asked to find the engine performance. Okay, let's move with the measurements. Okay, basic measurements to be undertaken to evaluate the performance of an engine on almost all tests are the following. So first, measurement of speed. So when you see speed, its unit is RPM. Okay, and what device you'll be using? That's tachometer. Okay, tachometer. So again, RPM just literally means revolution per minute. Okay, so you do have a mechanical tachometer and an electrical tachometer, and that is used to measure speed, basically. Okay, so this is your tachometer or speedometer in a vehicle. So once you have here an RPM, that's speed of your speed of your rotation in your engine. Okay, here's an example of your electrical tachometer and a mechanical tachometer. Okay, let's move with the electrical tachometer. So electrical tachometer has three-phase permanent magnet alternator to which voltmeter is attached. And then the output of alternator is a linear function of speed and is directly indicated in a volume voltmeter dial. Both electrical and mechanical tachometers are affected by the temperature variations and are not very accurate. Mhm. So that's tachometers. Okay, basically when you are measuring speed, you use tachometer. Okay, that's tachometer, and its unit, that's RPM. Next, we have for fuel consumption. So it is measured in two ways. So the first one is by volume flow. So the fuel consumption of an engine is measured by determining the volume flow in a given time interval and multiplying it by the specific gravity of fuel, which should be measured occasionally to get an accurate value. Okay, for example, you do have here a tank or a fuel tank, and this is connected to an engine. So you are asked here, you are given here uh, a hundred, I mean a 1 liter, okay, 1 liter gasoline. You're asked, you are given, and in about 10 minutes, you'll be testing if, or you're asked to get the fuel consumption of an engine. Okay, so this 1 liter will be input of your fuel tank. Then you'll be starting your engine for about 10 minutes, and then after 10 minutes you'll be computing for your fuel consumption by taking out again your fuel, then measuring it again, then dividing it by the time. Then you'll be have here a unit of liters per second. That's your fuel consumption unit when you are in volume. Okay? And the other method naman po is to measure the time required for consumption at a given mass. Okay? Just like that, for example, you are given here a 1 kilogram gasoline here. Then you are tasked to get the fuel consumption for about 10 minutes. Okay? Again, that's just the same process. You'll be um, getting after 10 minutes the weight, and then deduct that, then there have it. So if you'll be using this method, you get kilogram per second, as this is by weight. Okay, that's how you measure if your fuel consumption, or you measure fuel consumption. So that's by volume flow or by a given mass. Okay, so on a vehicle or automobiles, you do have here your fuel gauge, and that is how you measure the fuel on a vehicle. Okay, if it is here in the red one, that's empty, while if it's in this other side, that's full. Okay, let me move with the third one, the measurement of air consumption. So measurement of air consumption, we do have two. So we do have here the airbox method and viscous flow air meter. Okay, I won't be discussing this further, as this will be discussed on our fans and blowers, and also for the compressor. Okay, that's again for measurement of air, that's airbox method and viscous flow air meter. Okay, now let's move with the brake power. So for brake power, you are tasked to determine the torque and the angular speed. Okay, the torque measuring device is called dynamometer. Okay, take note of that. When you are asked to measure torque, the device you should be using is dynamometer. Okay, so we do have two main types of dynamometer. That's absorption and transmission. So when you say absorption, it absorbs the power output of the engine. And its perfect example are Prony brake, rope brake, hydraulic dynamometer. Okay, that's absorption. Absorption dynamometers, it um, absorbs a torque, and then it reads. Okay, and the other one is the transmission dynamometers. Its power is transmitted to the load coupled to the engine after it is indicated on some type of scale. These are also called torque meters. Okay, when transmission, it is in line. Okay, line being transmitted. Okay, so dynamometers are also called torque meters. Okay, again, we do have two types of dynamometers, that's absorption and transmission. And this is the measurement of brake power. Okay, we do get torque for brake power, and we multiply the torque with the given angular speed. Okay, that's measurement of brake power. And now let me discuss to you the friction power. Okay, so for friction power, this is just simply, you can write it as FP is equal to indicated power minus brake power. Okay, that's your formula for friction power. Okay, now let me have the um, four ways to measure friction power or to determine friction power. First is by Wheelan's line. So for Wheelan's line method, you do a graph with which you do have your gross fuel consumption and the brake power at constant speed. Okay, you'll be plotting those, and then um, you'll be asked to run your engine, and then it um, as it reads, or as it moves, until it goes again to zero. That's how the Wheelan's line method works. Okay, it will be extrapolated back to zero fuel consumption. Okay, next we do have the Morse test. So this Morse test is a method, though gives reasonably accurate results and is liable to errors due to change in mixture distribution and other conditions by cutting out one cylinder. Morse test. Again, we do have the first one for friction power, that's Whelan's line test. The second one is the Morse test, and the third one is by motoring test. Okay, you'll be running your engine until it to your desired speed. Then you'll be getting up your points. Okay. Then after motoring test, you do have your difference between indicated power and brake power. Okay, by your formula. Friction power is equal to indicated power minus brake power. And that's how you determine the friction power. Okay. Now let's move with the internal combustion engine lubrication system. So this is a discussion or refresher of your elective one. Okay, elective one is engine friction and lubrication system, if I'm not mistaken. Okay, this is just a review of lubrication system. Okay, firstly, let me discuss to you the lubrication theory. We do have two lubrication theory, that's fluid film theory and boundary layer theory. Okay, again, for fluid film theory, your lubricant is supposed to act like a mass globules. Okay, fluid film theory, your lubricant is acting like a mass of globules. And for boundary layer theory, your lubricant is soaked in rubbing surfaces. That's just it. So again, for fluid film theory, your lubricant is acting like a mass of globules. While for boundary layer theory, your lubricant is soaked in rubbing surfaces. And that's your two lubrication theory. Okay? Next, let me discuss the functions of lubrication. So first is to reduce frictional effect. Second is to create cooling effect. The third one is prevents leakage of gases. And the fourth one, or the last one, is serves as a cleaner. So first one, so the primary purpose of lubrication is to reduce friction and wear. So technically, when you're rubbing your hands, you're causing or making frictions. As you can see, if you're rubbing your fingers or your hands, it produces heat. But when you use lubricant, the heat, the produces heat when you rub your hands or fingers, it lessens. Okay, that means less friction is engaged. Okay, next is the creates cooling effect. As you put lubricant and you rub your hands, it doesn't produce heat more. Okay, it is cooling. I mean, the heat is dissipated. Okay, next one is prevents leakage of gases. So just like a cylinder piston, in a cylinder covered by the cylinder head, and you put here your lubricant here on this middle part, siguro. Then as your piston moves, the gas being trapped in the cylinder wouldn't leak because there are lubricants on the sides of the cylinder, I mean on the piston. So you trap gases. Okay, you trap gases, you prevent leakage of gas. And lastly, it serves as a cleaner. So lubrication keeps the engine clean by removing dirt or carbon from inside the engine along with the oil. And that's the function of lubrication. Okay, now let's move with the lubricant properties or properties of lubricant. So we do have 11. That's viscosity, viscosity index, oiliness, flash point, far point, cloud point, pore point, corrosiveness, oxidation stability, cleanliness, and carbon residue. Okay, carbon residue. So firstly, viscosity. So viscosity is the measure of internal friction of a fluid. That's just it. It is just a measure of internal friction of a fluid, viscosity. Now let me discuss to you the viscosity index. Okay, so viscosity index is a unitless measure of fluid's change in viscosity relative to temperature change. Okay, so kindly take note of this. The lower the viscosity index, the more viscosity is affected by change in temperature. While the higher the viscosity index, the more stable the viscosity remains over temperature fluctuations. Okay, that's viscosity index. Kindly take note of that. Okay, let's move with the oiliness. Oiliness is the property of lubricating oil to spread and attach itself firmly to the bearing surface as well as provide lubricity. That's oiliness. Ability to spread and attach itself. Oiliness. Next is the flash point. So again, flash point is the minimum temperature or the lowest temperature at which your um, fluid will flash or will ignite when contact with uh, when in contact with fire or ignition source specifically. Okay, that's flash point. While fire point is somehow related to flash point at which um, your fluid naman po or your fluid will continuously burn for 5 seconds. Okay? It will be burning or last up to 5 seconds. That's fire point. Next is the cloud point and pour point. Okay? So cloud point is the change in state from liquid to solid. Okay, that's cloud point. Specifically, lubricating oil changes its state from liquid to solid. It's cloud point. While pour point is the lowest temperature at which the lubricating oil will not flow or totally form wax or solidify. The lowest temperature at which the lubricating oil will not flow or totally form wax or solidify. That's pour point. Next is the corrosiveness. So it maintains the alkaline or acid-like solution to make the oil neutral. Okay, gives protection against corrosion, and the lubricant should not be corrosive. That's corrosiveness. Next, we do have the oxidation stability. Oxidation stability is just the resistance to oxidation. Okay, the oxidation stability, resistance to oxidation. Next, we do have the cleanliness. So cleanliness is just, it must be clean. That's cleanliness. And carbon residue is the deposits characteristics of oil. The deposits, yung mga tira. That's carbon residue. And that are the terms or properties of lubrication. That's viscosity, viscosity index, oiliness, flash point, fire point, cloud point, pour point, corrosiveness, oxidation stability, cleanliness, and carbon residue. Okay, I hope you do get those 11. And now, let's move with the types of lubricant. Okay, this is easy. Solid, semi-solid, and liquid. So when you do heard solid lubricant, that's specifically graphite. Okay, graphite is mixed with oil to lubricate automobile springs. Commonly, solid lubricants are used to automobile springs. Okay, next we do have the semi-solid. Okay, semi-solid lubricant is the perfect example is the grease or grasa. Okay, that's it. Semi-solid, medyo liquid na medyo solid. Okay, that's just it. And then the last one, the liquid lubricant, is basically obtained from animal fats, vegetable, and minerals. Okay, that's liquid lubricant. Perfect examples are vegetable lubricating oil and also the petroleum lubricant oil. That's the perfect example of liquid lubricant. That's vegetable lubricating oil and petroleum lubricant oil. Okay. Next, we do have the types of lubrication system. I know you're familiar with this. There's four. So that's mist lubrication system, wet sump lubrication system, dry sump lubrication system, and lastly, gear type lubrication system. Okay, let's start with the mist lubrication system. So mist, from the word mist. Yeah, mist. This is your spray, and that's mist. Parang binasa lang. Or you spray um, oil. Spraying mist. That's just it. Okay? In this system, lubricating oil is mixed with fuel while filling the petrol tank of the vehicle in a specific ratio. That's 12:1 to 50 to 10 as per manufacturer's specification or recommendations. That's basically mist lubrication. You're just like spraying. Okay? Let me move with the wet sump lubrication system. So wet sump lubrication system, you do have the splash, you have the fresher feed, and the combination of both. Okay, for that three, madali lang siya, or that is easy to understand. Okay, let me start with the wet sump, specifically splash lubrication. So when you say splash, for splash, so there's a sump of water that will be scooped or deeper. Okay, so in a splash lubrication system, you do have this scoop or deeper, and that would wet the system. Okay, that's scoop will scoop lubricant, then splash it to your system. Okay, this is how it works. So this is your scooper, this is your oil sump, that's typically lubricants, then it will scoop, then splash it onto your system. That's how the splash system works. It scoops or dips the on the oil sump, then splash it onto your system. Next, we do have the pressure feed. So from the word pressure, there's a pressure on your system. Okay, you do have your oil pumps. Okay, that's pressure. So if it works just like this one, so this is your oil filter and oil pump. So the pressure will be taking that oil, then splash it onto the upper system. Then the excess ones or excess oils will go onto the oil pan. And that's how pressure feed works. It pumps oil onto your system, then the scattered oil, residue, or scattered oil will go back to the oil pan. Then pump again, then the rotation moves with the system. Okay, that's how pressure feed system works. And lastly, the combination of both the splash and pressure lubrication system. So your lubricating oil is under pressure to main camshaft bearings and pipes, which direct streams oils against the dippers on the big end of the connecting rod. Bearing cup, thus crank pin bearings are lubricated by the splash or spray of oil thrown by the dipper. So that's the combination of both. You do have the scooper and the pumps with pressure. So this is how a splash pressure lubrication system is doing. Okay, I hope that's clear. We do have again for wet sump lubrication, we do have three, that is splash, pressure feed, and the combination of both, that is splash and pressure lubrication system. Okay, I hope that's clear on that. Okay, now let's move with the dry sump system. So in a dry sump system, that's a very organized system. Okay, since there's an oil tank outside your system, then there's a pumping onto your system, then the um, excess or the other oil that is not being used by the system will be pumped again to your outside tank. Okay, this is how it goes. So your pump will get the lubricant from your tank, then filter it, then move it to your system. Then the excess lubricants will go onto your sump. Then your scavenge pump will pump it out, then move it back to your tank. And then the system repeats itself. So that's how a dry sump system works. That's a very organized one. Okay, so that's dry sump system or dry sump lubrication system. And lastly, we do have the gear type lubrication system. So for gear type lubrication system, that's specifically for gears. That's for gears. So it is a 4-speed system of lubrication and uses oil contained in the bed plate as reserves. A gear type oil pump is driven from the crankshaft. The oil enters the pump and is carried around the pump casing by the gear teeth and is then discharged. The oil is prevented from returning to the inlet by meshing off the gear teeth. Oil is pumped from the bed plate to an oil filter and cooler and lubricating oil manifold. Okay, this is how it works. You do have here the inlet of your lubricant, then your system here or your lubricants here will pass through the system and then out on that, and then the other one moving here, then traveling outside. So that's how a gear lubricant or lubrication system works. A separate pipe supplies the oil to the turbocharger. A supply cold oil is critical for the turbocharger to lubricate the high-speed bearings and to carry heat away from the rotor. Okay, I hope you do get what gear type lubrication system is. That's specifically for gears. Again, we do have four. We do have four lubrication system. That's mist lubrication system, wet sump lubrication system, dry sump lubrication system, and gear type lubrication system. And for wet, we do have splash, we do have pressure, feed, and the combination of splash and pressure. Okay, so I hope you get what types of lubrication system is. This is just a recall or refreshing your past course. Okay, so I hope you have understood the chapter 1, and that is because this is the end of your chapter 1. Okay, so if you guys or engineers have questions with regards on our chapter 1, specifically entitled Internal Combustion Engine, do not hesitate to ask and ask me via Google Chat, and I'll be happy to assist you understanding those. Okay, thank you for listening and have a great day ahead. Thank you.